Video, guys. In this video we will discuss about an important chapter known as trigonometric ratios, which is basically been covered in class 10 ICSC board. So let's start with that chapter named trigonometric ratios. So in this chapter we have some particular formula which are as sine square theta plus cos square theta equals to 1 plus tan square theta equals to 6 square theta, 1 plus cot square theta equals to cosec theta. So in this chapter students basically have a problem regarding the proving portion, which is basically LHS or equals to RHS. So we will start with that type of numericals first, which is LHS equals to RHS type. We will take the first question as sec A plus tan A. Again 1 minus sec A equals to cos A. We have to prove on the right hand side it is cos A. So basically we will start with the left hand side, which is given as sec A plus tan A, and again 1 minus sin A. In the next line we will break sine and tan into sec and tan into sine and cos. So it will be written as 1 by cos A plus sin A by cos A, and this is normally written as 1 minus sin A. So basically we are getting here 1 plus sin A divided by cos A. Here cos A when taken LCM it will remain as cos A. So it is multiplied with 1 minus sin A. This will result to 1 minus sin square theta divided by cos A. So as we all know that 1 minus sin square theta equals to cos square theta, therefore cos square A divided by cos A will result to cos A, which is our RHS, equals to hence proved. The next type of numerical which we will practice is this type. Second, the question is as follows: 1 plus tan square A, 1 minus sin A, 1 plus sin A equals to 1. So we have to prove right hand side equals to 1. So left hand side we will take that. We will again break this this tan square theta into sin and cos. So again 1 plus sin square A divided by cos square A, again multiplied with 1 minus sin A, 1 plus sin A. So here we will get cos square A plus sin square A divided by cos square A. Again here 1 minus sin A, 1 plus sin A will result to 1 minus sin square A. Okay, fine. Therefore here we will get that 1 as sin square A plus cos square A will result to 1 into 1 minus sin square theta will turn into cos square A divided by cos square A, which will give us 1, which results to RHS. Hence the sum is proved. We will move on to our third sum, that is tan A plus cot A equals to sec A cosec A, which here we will solve the left hand side first. To get this value we will write that this as the tan we will break into sin and cos, sin A by cos A, and the cot into sin A cos A by sin A. Therefore we will get cos A sin A. Here we will multiply with sin A multiplied sin square A plus cos A multiplied, which will result to cos square A. Here this portion will get into 1 as sin square A plus cos square A equals to 1, and beneath it we are getting cos A and sin A. So we can also represent 1 by cos a sin a equals to sec a cosec a, because we all know that sec a equals to 1 by cos a and cosec a equals to 1 by sin. Therefore our sum is proved, this is equals to RHS, hence it is proved. Right? Sure. Next we will move on to our next sum, that is our fourth sum. 1 by sec a plus tan a plus 1 by sec a minus tan a equals to 2 sec a. So we will first take take an LCM of these two fractions, that is sec a plus tan a and sec a minus tan a. After taking this LCM, we will multiply the numerator with the following remaining part, that is sec a minus tan a plus sec a plus tan a. So here we will get the plus tan a minus tan a will get cancelled, and here it is 2 sec a. Under the denominator, which will form as sec square a minus tan square a. Here we know that 1 plus tan square a equals to sec square a. So 1 equals to sec square a minus tan square a. In this given part, we can also find sec square a minus tan square a is given, so we can substitute this value as 1 over here. So 2 sec a by 1 will result to 2 sec a, which is our right hand side. Hence our sum is proved. So we will move on to our next type of sum, next part, fifth sum our, that is sec a minus 1 divided by sec a plus 1 equals to 1 minus cos a by 1 plus cos a. We have to prove this out. So again, following the same formula, we have to break this sec into cos. So solving the left hand side first, 1 by cos a minus 1 and 1 by cos a plus 1, which in turn we will get as 1 minus cos a and 1 plus cos a. The cos a in the denominator will get cancelled, and we would get the desired result as this one, which is equal to our RHS, hence proved. So basically in this type of sum, we have to look into the RHS part, and then we have to make sure that we change adequate changes to the left hand side, right? So moving on to our next sum, we can see that our sixth sum is tan square theta minus sine square theta equals to tan square theta sine square theta. Again, seeing the right hand side, we can say that we have to change this tan square theta into sine and cos. So the left hand side we can write as sine square theta divided by cos square theta minus sine square theta, which will result to cos sine square theta minus sine square theta into cos square theta, which we can find that as taking sine theta common, we can say 1 minus cos square theta, and the denominator as usual it is cos square theta. So we can say 1 minus cos square theta as sine square theta, so we can write this as sine square theta into sine square theta divided by cos square theta, which in turn we can write as sine square theta and cos square theta as tan square theta, and this sine square theta will left alone and we can write as sine square theta. Therefore tan square theta equals to sec square theta equals to RHS, hence it is proved. So we will move to our next variety, that is the seventh one in this particular series we are doing. So the seventh one is given as cosec 4 theta minus cosec square equals to cot 4 theta plus cot square theta. Solution, we will again solve the LHS first, left hand side. So we can see that cosec to the power of 4 theta minus cosec to the power of 2 theta is given. In this particular case we can take cosec square theta as common, we can take that, and inside it we can get again cosec square theta minus 1. In the next step we can find that cosec square theta into cot square theta, as we all know 1 plus cot square theta equals to cosec square theta. So in step we can also write cot square theta equals to cosec square theta minus 1. So in this particular case we can also again write this cosec square theta into 1 plus cot square theta. So replacing this in this particular case as 1 plus cot square theta whole multiplied with again cot square theta, which in turn we will get as cot to the power of 4 theta into cot to the power cot square theta. After doing this particular operation, we can find this value is equal to our RHS. Hence our sum is proved. We will move on to our next sum. This is an important one in case of exam view. I am also marking it as important. So 2 sine square theta minus sec 4 theta minus 2 cosec square theta plus cosec to the power of 4 equals to cot 4 theta minus 10 to the power of 4 theta. So after looking this particular sum, we will start this operation with left hand side LHS. LHS is given by cosec, it is given as 2 sec square theta minus sec to the power of 4 theta minus 2 cosec square theta plus cosec to the power of 4 theta. We can write the sec square theta into what? Say 2 1 plus tan square theta minus, we can again write tan square theta plus 1 to the power of whole square minus 2 1 plus cot 1 plus cot square theta plus 1 plus cot square theta whole theta, right? After doing so, we can find out that, as we all know, sec square theta equals to tan square theta plus 1 and cosec square theta equals to 1 plus cot square theta. So in the next step we can say that 2 tan square theta plus 2 minus tan to the power of 4 theta plus 2 tan square theta plus 1 minus 2 cot square theta plus 1 plus 2 cot square theta plus cot to the power of 4 theta. Expanding this formula into a plus b whole square, we are getting this to part. After doing so, we have to simplify it. With the help of simplification, we can find that 2 tan square theta plus 2 minus minus tan to the power of 4 theta minus 2 tan square theta minus 1 minus 2 again cot square theta plus 1 plus 2 cot square theta plus cot to the power of 4 theta. With further more simplification, we can say it as cot to the power of 4 theta minus tan to the power of 4 theta as our RHS. This is your homework. How I got this out, please check on your own and write it down in the comment section, right? So up till here I am keeping this first part of this trigonometric ratio series. In the second half, I will come across those complex problems which students were looking for in this particular section. If you enjoyed this video, if you have if it is beneficial for you, please subscribe to our channel and please hit the bell icon to receive regular updates. Thank you.